Welcome back to our deep dive. Today, we're not just looking at the surface, we're diving into every inch of the 10-minute geometric wonder that is the harmonograph. We start back in Pisa. Galileo's observation wasn't just a moment of luck, but the beginning of human understanding of time and order in this vast universe. In 1844, Hugh Blackburn, a Scottish mathematician, designed what we now know as the Blackburn pendulum. This is the ancestor of the drawing machines we admire today. The foundation remains the same, simple harmonic motion. But let's look closer at the forces at play. Gravity pulls it down, while string tension keeps it on its path. Mathematically, the pen's position is defined by a system of parametric equations. The variables A and B represent frequency, while D is the phase or time difference between.
Behind every question lies discovery. I'm Saluna, and this is SciCurious, where we uncover the science shaping our world.
Happens when we change the ratios. From a simple circle at a 1-to-1 ratio to an elegant figure eight at 1-to-2. Every number has its own unique shape. This is the physical manifestation of musical harmony. A perfect fifth interval, or a 3-to-2 ratio, creates this iconic three-lobed pattern that is deeply satisfying to watch. Now, observe this three-pendulum machine. One for the x-axis, one for the y-axis, and the third is often used to rotate the drawing table itself, adding a third layer of complexity. You can make a simple version at home. Use a sand-filled bottle as a weight, hang it with 2 meeting strings, and let the leaking sand paint its path on the floor. Damping isn't just about losing energy. In art, damping is the dimension giver. Without friction, the pen would repeat the same path forever, and we'd never get this spiral depth. It's like the universe itself. Everything moves toward equilibrium. These patterns are reminders that beauty is often born from the process of decay and energy shift. Let's enjoy a gallery of rarer patterns. This sharp star pattern is produced by a very specific frequency ratio and very low damping, truly like a frozen crystal. This flower-like pattern takes over 15 minutes to draw in real life. The machine's patience produces detail impossible for even the fastest human hand. In the digital age, algorithms can mimic this process. Yet, art collectors still seek physical pieces for the tiny irregularities caused by dust or a breeze, the soul in the machine. Watching a harmonograph work is a form of meditation. It teaches us about patience and how small things, if repeated with consistency, can create something grand. Mechanical art continues to evolve. From laboratories to art galleries, these principles remain timeless because they are based on the physical laws that underlie our existence. We have traveled these 10 minutes together. Remember, math isn't just numbers on a board, it's the beauty spiraling all around us. Thank you for watching.
There's always more to discover. I'm Selu, and this has been SciCurious. Stay curious, and I'll see you in the next wonder.